Hello friends, in this video we will see the rope friction. So what is the rope friction? Consider a pulley or a drum, and over this pulley one rope will be there. And the friction mean between the rope and the drum or rope and the pulley when transfer the power. Then this concept we will see with the help of example. So first we will see the introduction. A pulley system involving a belt or rope is a mechanism where friction plays a crucial role in the lifting a load, transferring power or applying brakes to stop movement. Now this concept we will see the one diagram. Consider a drum or pulley, and over this pulley one rope will be there. So at either side of this, one side what W weight will be applied there, and another side there is a force P will be there. And wherever there is a contact of rope and the drum is there is a tangent to the drum is there. So angle between this rope and the drum, it is called as the angle of contact is there, and this is the denoted by the theta, and this is the rotation direction. Now we'll see this concept again with the help of tensions. So at one side there is a tension T1 and another side a tension T2. So what is the tension T2 and T1 is? We consider here the tight side applying force. There is a P is there, so this is the T2 will be there. So tension in the tight side, and slack side there is a tension T2, T1 is there. Now we know the relation in between the T2 and the T1. So we already derived this equation. So we directly see here the equation or relation in between the tension in the tight side and tension in the slack side. So T2 is equals to T1 e raised to mu theta. So what is the mu and theta? Mu is coefficient of friction and theta is angle of contacts. So one by one we will see here, where T2 is force in tight side, T1 is force in slack side, mu is coefficient of friction, and theta is equal to angle of contact between the rope and the drum. So this is the introduction about the rope friction. So here important is what? There is a relation in between the tensions in tight side and the tension in slack side. So directly we will see the numerical. So what is the numerical? In figure, the coefficient of friction between the rope and the fixed drum is 0.2 and between the other surfaces of contact is 0.3. Determine the minimum weight W to prevent the downward motion of the 2000 Newton block. Here consider the W weight one block and the 2000 Newton one block. So what is asked in the numerical and what is given in the numerical? So here friction between the rope and the fixed drum is 0.2 and between other surfaces of contact is 0.3. So in between the rope and the drum is 0.2, and other surfaces means what? Here in between the blocks surfaces there is a W and 2000 Newton, and floor and the 2000 Newton block. Here we will consider the W having the weight W is block A and 2000 Newton having the block B. And what is asked? What is the minimum weight of W to prevent the downward motion of the 2000 Newton block? Here you have to restrict the sliding motion of 2000 Newton block, which is sliding toward the downward sides. And here slope is given. Angle is given in terms of slope. So what is the slope? 3/4. So we will calculate the angle also using this slope. So solution. So we will see here the one by one or step by step the solution. So first we will calculate here the angle. So tan alpha is equals to 3/4. So alpha is equals to, there is a 36.87. So first consider here the block A. So draw here the initially free body diagram of block A, which is having the weight W. Consider here the block A and its weight W and tension in the block A, tension T1, then tension T1 is in right side, so opposite to this the tension T1 there is a frictional force will be there, so frictional force is F1, and from the ground side or from the surfaces of 2000 Newton there is a normal will be act to the block W, which is having the N1, and alpha angle is given is 36.87. So one by one we will solve here the these unknowns. What are the unknowns? F1, N1, T1 and W. We have to calculate here the W value, which is to prevent the sliding motion of 2000 Newton block. So consider the equilibrium condition. What is the equilibrium condition? Taking the summation of f of y is equals to 0 and taking the summation of f of x is equals to 0. So where is the direction of y and where is the direction of x? So we will see here. So taking first summation of f of y is equals to 0. So you can see in the diagram where is the y direction. So this is the vertical direction is the y direction. You can see it. So along y direction what are the forces? There is a N1, then W, again resolve into two components, there is cos alpha and sin alpha. So here the W cos alpha is in vertical direction plus N1. So here we will consider the sign conventions. What are the sign conventions? Upward positive, downward negative, right side positive, left side negative. And if we take wherever there is a movements are there, so clockwise positive, anti-clockwise negative. So taking the summation of f of y is equals to 0. So plus N1 upward, then downward W cos alpha minus W cos alpha. Put the value of alpha and simplify it. There is a 0.8 W. Then we have the relation, that is mu is equals to frictional force upon normal. Mu is what? Coefficient of friction. So again simplify it, F1 is equals to mu into N1. So N1 is, we have already calculated, that is 0.8 W. So mu is 0.3 for the surfaces, is 0.3 into 0.8 is equals to 2.24 W. So this is equation number 2. So taking the summation of f of x, equilibrium condition, and along the x direction, where is the x direction? You can see in the diagram, this is the x direction. So along the x direction, T1 is there, W sin alpha is there, and F1 will be there. So according to sign convention, take the plus T1 minus F1 minus W sin alpha. Again simplify it, T1 is equals to F1 plus W sin 36.87 angle. So again simplify it, F1 is already calculated from equation 2, substitute this value, F1 0.24 W plus 0.6 W. So again simplify it, that is T1 is equals to 0.84 W. This is equation number 3. So we simplify our free body diagram of drum and its tensions. Drum and its tension. So tension is in either direction is T1 and T2. So angle of contact of rope with the pulley is here consider or tangent this rope to the drum at that angle is 180 degree. So equals to, this is in radian, that is pi radian. So friction equation for rope is what? We have already seen the relation between the T2 and T1. T2 is what? The tension in the tight side, and T1 is the tension in the slack side. So T2 is equals to T1 e raised to mu theta. So what is the mu here? The rope and the drum is frictional force is given 0.2 and angle is pi radian. So put these values, T2 is equals to T1 e raised to 0.2 pi. So T2 is equals to 1.874 into T1. So substituting the T1 value from equation 3. So equation 3 is what? 0.84 W T1. Okay. So T2 is equals to, again simplified, 1.574 W. So now we'll to move the block B. So what is the block B? Having the 2000 Newton weight, and T2 is the tension, angle alpha. So from the block W there is a N1 will be there, normal, and from the floor there will be N2 will be there, normal. So here is the T2, tension is in right side, but block is sliding the downward side. Once again I repeat here, the tension T2 is in right side, but block is sliding the downward side. So frictional force is in opposite direction, that is right side. So F1 frictional force between the block W and the block 2000 Newton is F1, and in between the floor and the block 2000 Newton, that is F2. So taking the equilibrium condition, where is the y direction, that is you can see in the diagram, this is the y direction, and 2000 Newton, this load is again resolved into cos and sine component, cos alpha and sine alpha. So taking the summation of f of y, so plus n2 minus n1 minus 2000 cos alpha, then n2 minus n1 is equals to 2000 cos 36.86. So n2 minus n1 is equals to 1600.20. So n2 is equals to 1600.2 plus n1. So n2 is equals to 1600.2 plus n1, we have already calculated here 0.8 W. So put this value, then we have the relation, that is mu is equals to F2 by N2, frictional force upon normal. So this apply for the floor and the 2000 Newton block. So and frictional between them is what, is 0.3. So put this value of N2 from the above equation, that is 1600.2 plus 0.8 W into 0.3. So multiply with this and simplify it. So we'll get the F2 is equals to 480.06 plus 2.4 W. Taking the summation of f of x is equals to 0. Again this x direction is where, is the along this horizontal direction. So this is the plus f1 plus f2 minus 2000 sin alpha plus t2 is equals to 0. So all the values of f1, f2, alpha and t2, all values put in this equation from the above equations. We have already calculated the f1, f2, alpha and t2, and simplify it, we will get the W value is equals to 350.37 Newton. So in this way we can solve any rope friction problem. So we will see